Minutes before we get started, but you know what? I'd just like to say hello to everyone. I got to ask, who here's a first-timer here at Pastime? Would you mind raising your hands and sharing? Fantastic. Now, in the 5 minutes that we have before we get started, I'd like to ask something of all of you. Would you mind turning to your neighbor, hopefully someone that you don't know, and just introducing yourself? Tell them your name, what you do, and where you're from. If you would do me that favor, I would really appreciate it. Plenty of seats are still available over here on the right-hand side of the room. Come on in, please. Welcome, welcome. There's plenty of seating over here on the right-hand side of the room. Come on in. Seats right here in the middle as well. Still plenty of seats over here in the middle and on the right-hand side of the room, so please come on in. Welcome. We got another 2 minutes before we get underway. Last chance to run away before we lock the doors. So before we get underway, for those of you who participated in my little exercise, I just want to say thank you. You just participated in the most important thing here at this conference. It's not about any of the sessions. It's about meeting someone new and expanding your personal network. I don't know about you all, but I've had many opportunities over the years for new jobs and new positions come to me because of people I know. And I know I'm definitely not a walking encyclopedia with a photographic memory who knows everything, but I know people who do know stuff. So that's what's most important about a conference like this, is not only just attending sessions like this, but meeting someone new and meeting someone who has a different set of skills and expertise that you do. Or even sometimes just having that person who can be that sounding board for you, just to say, hey, gut check me here. Does this sound right? Yes or no? Even if you all know the same exact stuff. So thank you for participating in that. Thank you for meeting your neighbor and greeting. Please come on in. We still got plenty of seats, dead center in the center. We also have more seating over on the right, and we'll be underway in just one. Well, actually, it's 2 o'clock. So come on in, come on in. Welcome, everyone, to a practical deep dive into I/O for the T-SQL Performance Tuner. My name is Andy Yoon, and I'll be your host for the next hour and change. A little bit of information about me and my introduction. I'm a field solution architect with a company called Pure Storage, and I've of course been working with SQL Server for a very long time. The one number up here that kind of scares me is that I've actually even been speaking for 10 years now, which is kind of terrifying to me. Of course, I used to be based out of the Chicago area. I see some Chicago friends in the audience. Good to see you all again. And then my contact information, of course, is up there as well. The key thing to remember is SQL Beck. No C, it's just B-E-K. And this will, of course, be available later on at the end. The reason that is important because all of my slides, of course, will be available up on my GitHub. Because there's going to be a lot of material in this particular presentation. If you don't grab it right now, don't worry. The URL will present itself one more time at the end. Please come in, everyone. There's still plenty of seats in the middle. There's more seating available on the right. Come on in. Welcome. I'm just doing my little intro here so you can come get to me. Come on in. Welcome. Welcome. So the one thing to understand about me, though, from a past perspective is this. I've been a SQL Server guy for a long time. But I wasn't as much of a storage or an I/O person up until I actually joined Pure Storage a few years ago. So for myself, storage for a good chunk of my career was kind of a black box. And I'm sure some of you can relate to it, which is why you're here today. So what I kind of am putting this session together for is for people like Andy 5 years ago. So let's just kind of set the stage and get started. Oh yes, and I am, by way of introduction, Deborah Melkin is my amazing spouse. She is also one of the data platform women in technology co-leaders. She'll be here in a few minutes. She just finished a luncheon. And you also will be meeting Sebastian, our dog, who of course welcomed you on the prior slide. And you'll be seeing quite a bit of him over the next hour and change. All right. So to kind of set the stage, many of us have been in this case where, we get into work or we get work started, and it's a nice, quiet Monday morning. I'm going to sit down with this awesome pastry from Modern Pastry. We got these amazing cannolis out in the Boston area. And, it's a nice, quiet morning. I'm just settling in, and all of a sudden, the quiet of Monday morning is shattered. We're starting to get alerts. We're getting pinged about stuff that is blowing up. This is all a life that almost all of us have lived through to one extent or the other. All right, fine, Sebastian, what's going on? So Sebastian cracks open the SQL Server error log and shows us that, we have the dreaded SQL Server has encountered blah, blah, blah occurrences of I/O taking longer than 15 seconds. How many in here have ever seen one of these errors before? Most of the room, good, good. And when you've seen this error before, since most of y'all raised your hand, how many of you panicked and said, oh no, where do I start? How do I start digging into this? And because there's definitely been times in my career, especially earlier on, where I'm like, oh crap, I have no idea where to go next. So I felt very much like Sebastian here, trapped in kind of like, what do I do? So the thing about I/O, and one of the reasons why that error message can be so daunting, is that I/O in of itself is very expansive. It covers a lot of different subtopics. So to that end, this presentation, of course, is going to try and deep dive into a lot of those aspects of I/O. And I am going to try and do this in a more, this is not going to be an intermediate session. I'm going to expect you to have basic knowledge of, certain basics and that sort of thing. So I'm not going to be covering that. But at the same time, instead of going all 500 level and debugger and showing you the call stack and such, I am going to try and also keep this in a practical level as well. So we're going to be kind of riding that roller coaster here of going a little bit deeper, but also trying to give you takeaways that you can utilize back at home, back at work. Now, I also want to point out that my target audience for this is for the T-SQL Performance Tuner. But notice that I said Performance Tuner, not necessarily developer. Before I continue on, let me actually get a quick poll in the room. How many people in here would consider yourself more of a T-SQL developer? Please, raise your hands. Okay, maybe about a quarter to a third of you. How many people in here would consider yourselves more of an operational DBA? Okay, fantastic. The vast majority of folks in this room. Anyone from somewhere falls into a different category aside from one of those two? Okay, just like 2 or 3. Cool. So you all are my target audience. But what I really wanted to drive home the point is this. Even if you are primarily a T-SQL developer, is this session for you? Because as I mentioned to you all earlier, Andy 5 years ago didn't really know all that much about storage, didn't really know all that much about the I/O path. It was very much that black box to me, because I just slung code. That's what I did for the majority of my career. So I talked to a T-SQL developer who's been doing this entire time, my wife Deborah, and this is kind of a summary of why she believes, as someone who has never worked in an operational role, why it's still important to have at least familiarity with the underlying stack. Okay? So in either case, hopefully you'll come away with a better appreciation after this particular presentation. And I would also argue that for many of us, as we progress through our careers, even if we start off just slinging code, that as we progress into getting more and more into perf tuning, that you start as a T-SQL developer, but then you become more of a T-SQL performance tuner. But once you really want to start perf tuning everything, you need to go beyond just a code and look at your SQL Server environment in a more holistic fashion. And that's kind of what this presentation is also going to be all about. So, yep, you don't have to know everything, but it's ideal to be familiar with many things. So with that, I do like to set some foundations immediately off the bat, just to make sure that we're all on the same page on certain key aspects that will come to haunt us the rest of this particular presentation. And the things that I want to be front of mind for everyone is that everything will, of course, start with our T-SQL query, which gets passed to the query optimizer. And then the query optimizer comes up with an execution plan, okay? So the point to all of this is to drive home and remind everyone of the fact that T-SQL is a declarative language. Tell me what you want, but not how to go about doing it. So if you've been at any of my other presentations, you know I love analogies. So one thing that I like to do is cook. Deborah and I also like to go out to eat awesome food, but if I'm cooking something tonight and she's like, you know what, I want you to make this, or I want you to make this particular dish, she'll ask for what she wants in the end, this particular dish. But she's not going to necessarily be telling me how to cook that particular dish. She's not necessarily going to be telling me how to, cut the onions this way or chop up the broccoli that way. Just like when you go to a restaurant, you order something for dinner, but you're not going into the back of the kitchen to tell the chef, I want you to do this, 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 and this. And in the same way with T-SQL, your query, what you are asking for a result set in the end. But you're not necessarily telling SQL Server exactly what to do. Yes, there are ways to cheat. We're not talking about those different things today, just in general context. So of course, the way that all of this translates back to us in the SQL Server world in an execution plan are our access methods. So in this case, a simple example here happens to have a couple of clustered index scan and seek operations. These are the actual operations that the storage engine will do to retrieve and work with your underlying data. So let's talk a little bit about the execution plan workflow. I'm starting off with this clustered index scan. So what's going to happen, underneath the covers is that one aspect is that we're going to talk to the buffer manager. Of course, remember the buffer's RAM, and we're going to ask the buffer manager, hey, are the data pages that I need, are they in the buffer pool right now? If the answer is yes, cool. I'm going to read that data page, and that will manifest as a logical read operation for us. If you're using something like statistics.io, that's the type of output you will see there. Now, on the other hand, if the data page is not in the buffer pool, we must fetch that data page from disk, and that manifests itself as a physical read. Now, I do want to clarify on one particular point, is that immediately thereafter, we still must read that data page again from the buffer pool, so that will manifest as yet another logical read as well, okay? Now, who's actually doing this work of doing this index seek and doing this index scan? Underneath the cover, SQL Server is passing commands, I/O requests, to your operating system. In this case, for 95% of us, that's of course going to be Windows. And it's Windows that's going to dispatch the I/O by using the CPU and first checking, hey, do I happen to have something in RAM? And of course, if something is in RAM, it's going to be really fast for us, just from the physicality of the underlying physical architecture. And RAM is ideal. I don't really necessarily want to go out to disk if I don't have to. But of course, if we have to do physical operations, then Windows will accordingly, go across, across the wire, across physical connectivity like the PCI bus, to underlying disk to retrieve our data pages. So let me kind of take you on a refresher of what physical pathways of your I/O happen to look like. In some cases, we still happen to have bare metal SQL servers, or back in the day, before virtualization and such, we just had bare metal SQL servers with direct attached storage, storage directly inside of your server, so that is the simplest path. Of course, I'm generalizing here a little bit, but there's not much to go through, because all I have to do is just traverse the PCI bus on my motherboard. But of course, most of us nowadays work with storage arrays, SANs. So instead, you're now going to be traversing over an HBA adapter of some sort. I'm using this term a little generically here, but basically you have to go through some kind of adapter to then go out to your storage fabric. Again, I'm using this term a little bit generically, but it's the switches and the underlying network or the storage interconnect in order to reach your SAN. The point is that you have many, many more places that you must traverse in order to retrieve data pages. And in my experience, probably 90% of the SQL servers I see out there are virtualized on VMware. So if you are virtualized, then there is some layers on the virtual stack that you must penetrate and go through, especially if, for example, you're using a virtualized file system. Many of us are in the world of VMFS. Are you more familiar with the terms VMDK files, right? So that is a virtualized file system. So there's more elements in the stack because your ESXi host or your VMware host, of course, has to manage those file accesses from that level before you even get out to bare metal, to then go over a bare metal HBA adapter and then your underlying storage fabric. So the key takeaway here is that our storage or our physical pathways have gotten just much more complicated over the years. There's many, many more places where I/O has to traverse and potentially get bottlenecked. So the key takeaways to remember from this simple foundations chapter or segment is, of course, disk reading, disk writing has those many layers as we just kind of reviewed. And in the end, frankly, access from memory is always faster. If I don't have to go to disk, I don't want to go to disk. I'd rather just work out of memory if I can. All right, Sebastian, sorry we've left you alone for a good couple of minutes. We're coming back to you now. So back to our story. So the error, the 833 error, as Microsoft defines it, is a blah, 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 blah. SQL Server has issued a read or write request to or from disk, and it's taken longer than 15 seconds. So that's a heck of a long time in the world of databases, right? I don't want to be sitting around waiting for 15 seconds. Heck, I don't want to be sitting around waiting for 5 seconds even. So let's dissect how this error message is even tracked internally. So first of all, it's checking to see if any I/O has been pending for longer than 15 seconds. But here's the thing. It's not being checked constantly. It's only being checked once every 5 seconds. And then it's only being written out to the error log once every 5 minutes. Yes, Sebastian? What do you think? Oh, yes. Aren't there some coverage gaps here? What happens if I happen to have an I/O that's been pending for 13 seconds and then we check it? And then it completes at the 16-second mark. It'll be done, but then when we check again 5 seconds later, it'll be lost because it wasn't pending for longer than 15 seconds at any of the given 5-second intervals. So you may actually be having a little bit more of this and just not necessarily realize it. So just understand that the numbers that you see, because it's a summary error message in your error log, is that it could actually be even worse. Like if you see 700 occurrences, it could be higher than that actually. So don't necessarily go by that hard number because of the way the reporting and the recording essentially has a gap. Now, before digging into any of this, whenever you start seeing one of these errors, I strongly encourage you to be asking questions. You need to ask a lot of critical questions. Has this always been happening? Has this particular error message just started manifesting? What is the pattern behind it? Did something change recently? Those are the different kinds of common questions that we all need to be asking ourselves whenever we have any kind of performance issue or challenge or headache. And in this case, you not only need to ask questions of the applications that are directly running on your SQL Server and your underlying query workloads, but because you want to be mindful of the entire stack, you want to ask the other players who own the other elements in the stack, like your VMware admin, for example. So here's a little story that's, kind of takes things into the practical world. Thank you, Sebastian, for that little reminder. So here's a tale from the trenches from one of the customers that I've worked with. So they recently upgraded their storage. They actually bought some of our hardware, and they were generally pretty happy with it. But then, of course, they ran into a big old performance headache, a big old performance problem. So they started an escalation room, got a bunch of us engaged, myself included. So, we had the DBA in there, we had the Windows admin, we had a bunch of people. We had people from the entirety of the stack, or so we thought. So one aspect about your storage fabric is that typically you're going to be going over fiber channel or Ethernet if you're going to be using iSCSI. And in this case, this customer had changed from fiber channel over to iSCSI, which is Ethernet. Who's missing from that escalation team? Well, yes, Sebastian, no one did in this case talk to the network team. So let me paint a picture for you as far as what actually happened in this particular scenario. So we had this brand new SAN here, and they happen to have two top-of-rack switches for redundancy purposes. We want that redundancy, right? So if one switch fails, as it did, cool, the other switch should be able to handle everything. But because this was the first time that they were working with iSCSI, they had a misconfiguration. So instead of being able to handle the full weight of the workload and give you the full throughput that would be expected in a failure scenario like this, it got cut in half. But the network team didn't bother thinking about checking about that because they're like, oh yeah, we got two top-of-rack switches, one failed, we got this handled. They never bothered talking to anyone else, and all of us on the escalation team on the database side never bothered talking to the network team because traditionally they never had to talk to the network team before. But now they do, but they just didn't really think about it until we all started asking the hard questions, and then we finally all got connected. So really this is a lesson in communication and making sure that you involve everyone. All right. So with that, we do need to start troubleshooting somewhere. So let's start from the top. Yeah, Sebastian, go take your nap. So of course, many of us in the SQL Server world, we like looking at SQL Server wait stats, and that's a fantastic place to start. I'm a big fan of that. But one of the other things I also encourage you to check, if nothing else, is latency. But you want to check latency not in one, but two different places. You want to check latency in the DMV, the DMIO virtual file stats, but you'll also want to check latency on the Windows level using a perfmon counter, because you want to eliminate one particular scenario. So this is where we're going to do a little bit of a deep dive here. What happens if SQL Server is reporting ridiculously high latency, but your Windows perf counters are not? That almost always means that you're subject to a filter driver issue. How many people in here have actually heard of a filter driver? Okay, but how many people in here have actually heard of CrowdStrike or antivirus or corporate security spyware? That is fundamentally a filter driver, a piece of software that lives in between in your stack that's essentially interrogating your I/O. So do you know if you happen to have these filter drivers in your environment? Most of us do to some extent or other. And of course, just like any software like CrowdStrike, a bug can get in there and potentially start causing you some crazy old headaches. So this is actually a really cool command. I'm not going to deep dive into this particular topic, but this command will actually show you the filter drivers that are present on your machine and the volumes that they are interrogating. Now this example here, there's just a handful of filter drivers because you'll always have some, of course. But this is on my virtual SQL Server machine that's just my VM. So it's a vanilla VM that's just running SQL Server. But my personal laptop here, which happens to have many, many other things on it that's running on it. I also play video games and stuff on there. There's a whole heck of a lot of other software on this machine, and you can see how there's a much crazier list of filter drivers. If this is a problem for you, you're definitely going to want to engage a Windows expert because this gets really, really deep, really esoteric. There are more resources at the end of this presentation. But again, it's just one of those dusty corners that most people will not encounter, but when you do, now you know where to look. So the next thing you need to ask yourself beyond this is, are you actually saturating your storage? Not from a latency perspective, but from a throughput perspective. So, maybe I'm doing some work here where I want to be driving around 8 gigabytes per second. I'm trying to do some heavy workload of some sort. And, I know my SAN is capable of 25 gigabytes per second, for example. I know I invested in something really powerful, really, really awesome. But you also need to be mindful of, again, what is the throughput limitations or bottlenecks all along the entirety of your stack, right? So in this simplistic example here, my HBAs and my storage fabric is only capable of about 4 gigs per second. It's also very important that you monitor your entire stack. And if nothing else, even just knowing how to query your queries and your workload is quite critical. Here's another story that actually just happened a couple of weeks ago. We had a customer that was complaining about their storage array getting crushed, and we started digging into the telemetry information, and it's like, yeah, it's getting crushed every single day at 5 in the morning. Okay, cool. What are you running? They had no idea. It's like, wait, what? Really? You don't know what workload's running? No, we don't. Well, from our telemetry, I'm telling you it's this particular SQL server, it's this particular VM. I can tell you that much from what we can see, but you have no idea how to query your own queries? No. So please learn how to do that as well. Those are skills, pieces of knowledge that are important for you to have, even if you don't necessarily live in code, as an operational DBA. You need to know how to dig into your workload and find out what is running at any given time to then better understand why you may be seeing a performance headache of some sort. So the thing about our queries is that one thing that many developers don't necessarily appreciate at all times is that they're all constantly competing for resources. When I was a developer, especially earlier on in my career, I would be focused on this big, hunk of code and trying to performance tune that, but I wasn't being mindful of the fact that this piece of code lived on a SQL server that had to share CPU and had to share RAM. I have to be more mindful of the overall workload here, right? Because we're all constantly fighting over resources. Fine, Sebastian, I'll feed you. So you know what? I'm going to use Sebastian's dinner time to give you a simple analogy. So of course we have Sebastian's doggy food bowl here. It's only of a certain size, right? And Sebastian is supposed to have mostly just this little small kibble here, and a couple of larger kibbles that you see up there are more of his treats than anything else. We don't want to give him too much of the really fatty types of food, right? So his food bowl will be filled up about halfway with a certain mixture of stuff. But of course, Sebastian, being a dog, wants the good stuff. We all want the good stuff, right? I want more bacon in my BLTs. I want the extra fat in my burgers, for example. So we get into a little bit of a conflict and a fight because we each want more resources. We want different type of resources. And of course, in this case, his dog food bowl is also finite. So eventually, as we're struggling back and forth, we spill over because that bowl can only fit so much. You can't, just get everything that we want necessarily because that bowl is only finite, and each of us have different priorities or different reasonings for doing things. And in the same regards, think about your queries versus the other queries and workloads that are running in your environment. So CPU, it orchestrates I/O. If you were in Anthony Nocentino's presentation earlier, he made the quip that CPU is core to your I/O. Haha, if you think about that one. But of course, your CPU cores are what are driving I/O. If you don't have cores to drive your I/O, it's not really going to go anywhere. Hold that thought. We'll actually be coming back to that one. Now, one of the things that I often find in many workloads is not only just you have code that does a whole heck of a lot of logical reads, is reading too much data into the buffer pool, but one of the hidden performance killers that I feel like has only in more recent years gotten a lot more press and a lot more visibility is that of memory grants. because what I often find in many SQL Server environments is that we just don't necessarily have enough RAM. And one of the consequences of poorly tuned queries is oftentimes you will get very large memory grants, or memory grants that are not large enough but wind up needing more. And when they wind up needing more than what the query optimizer thought it needed because of bad estimates and other consequences from the code perspective, you spill over to TempDB. Remember what I said earlier about going to disk? Going to disk is not necessarily a good thing. Well, when you spill to TempDB, now you're actively writing to and from disk, because now you must utilize TempDB in order to complete your query. So these are all things that I argue that you should be very, very mindful of. And there are entire presentations about memory grants and such as well. Fine. Maybe the workload has been absolved. In this case, as you're doing your troubleshooting, it's not the workload. We've already kind of baselined it. We've kind of figured out what's going on. So now we need to start looking at the physical I/O path. We need to actually start looking at the underlying hardware and seeing what's really going on, kind of beyond the purview of the SQL Server. And if you go to Microsoft's page about the 833 error, the term I/O path is mentioned a whole bunch. It's one of those things that you most likely will have to dig into if you're trying to dissect the 833 error in your environment. So again, we kind of touched upon this earlier when I covered the I/O pathways, but you need to research and actually look into what each element, your HBAs, your actual server specs, and so on, what is each element capable of? And you want to be looking at stats like, what is the throughput capabilities? What are the IOPS capabilities, for example? And hopefully you have a way of capturing and monitoring this activity as well. Because a lot of the things that we DBAs will use only have visibility from the Windows perspective. Hopefully you have other tooling, other capabilities to look at things from an overall stack perspective instead. So to kind of help illustrate that, I'm going to share yet another story with you all. So a couple of years ago, before SQL Server 2022 was out, I had the privilege of doing some testing for Microsoft about backups. So we set this particular scenario up in my lab. So my SQL Server was backed by one particular SAN, and we were writing to an SMB share for backup purposes out to a different piece of hardware. So it was actually traversing two different storage fabrics, one fiber channel, and then on the outside, or on the other side, a network or an Ethernet fabric in this example. And for some reason, we were only able to get backup throughput of around 3 gigabytes per second, which was really kind of confusing because the SAN that we were sending all of this data to was capable, more than capable, of ingesting upwards to 100 gigabytes per second. It had a whole heck of a lot of horsepower. And my source SAN should have been able to service up data at a rate of 25 gigabytes per second. And this was in an isolated lab environment where no one else was doing anything. So why am I not getting the maximum possible throughput? So in this particular case, we had to walk the entirety of the stack to find out, what is each element capable of. And what we wound up finding out was not only the HBA adapter was only capable of 3 gigabytes per second, but it was physically inserted or installed in a server in such a way that we had something called a riser card. I'm not a hardware guy. I never even knew what a riser card was up until I encountered this, where we actually had someone else in the data center open up our server, take some photos, sending it to us. So in the PCI slot, the HBA card was not just sitting only in the PCI slot, but there's this other card there, and then there's my HBA card and another card hanging off of that extension slot. So it essentially cut the PCI capability or the bandwidth in half. So, and I didn't even know that until I actually cracked open the manuals and then had a guy in the data center actually taking photos of that. But it's one of those oddball things of like, I've never encountered that before. I see someone up here nodding their head. It sounds like you've experienced that one before, yes?
Very good.
Very good.
Hardware failures. Yep.
Yep. Yeah, the gentleman up front was just commenting, having a sysadmin background, that he's seen this type of stuff before as well. But, for many of us DBAs, myself being a good example, I've never seen this type of thing before. So it's a good example of, oftentimes you have to find that needle in the haystack when you're dealing with I/O headaches. All right, fine. So life continues, and you know what? We've opened up our wallets and we've upgraded everything. We've spent some money, and we're going to get some really, really awesome storage. We're going to get rid of our spinning Rust. And we bought some flash storage, maybe from a certain orange company. But then Monday comes along, and we start getting those alerts again. Performance has tanked. And Sebastian, of course, is pretty upset because, we just spent a whole bunch of money. He shared our treats with us so that we could have really awesome fast storage. So why is performance tanking all of a sudden, even though we've just upgraded everything? Or did we upgrade everything? We upgraded everything physically, right? Well, hold on for a second. What do I mean by upgrade is a comment from the audience. So we physically upgraded everything, but here's the thing. To explain this particular performance issue or challenge, I'm going to introduce you to a concept called queuing, something else that I wasn't familiar with up until just only a few years ago. So understand that a queue, that is the construct that contains I/O requests to be processed. Now, this is a term that, as I was learning this whole concept, kind of always confused me, queue depth. But really, I like to think of it as the queue depth limit. How many I/Os can I happen to have in this particular queue? So I like to think of it more as a limit. Some people will not necessarily use it in that sense. Some people I've actually seen will use queue depth to really define queue length. How many elements do I happen to have in the queue right now? But I want to draw this very clear distinction because, again, this was something that confused the heck out of me. So we have our queue depth limit and our queue length, okay? And the other thing that I found confusing is that a queue, to me, is kind of like a line. So, I'll be waiting at the gas station, for example. So I'll pull up to the gas station, I'll start fueling up my car, and then other cars will queue up behind me. They can't fuel up. But in the world of I/O, it's more about the queues representing the people who are being fueled or serviced at that point in time. So in this case, my endpoint, of course, is that gas station, and I happen to have 4 fuel pumps, which means I can fuel up 4 cars simultaneously in this particular case. Or, in this example, there's 1 car hanging out here. My queue length is 1. A couple more cars pull up. My queue length is now 3. Okay? And by the way, the amount of time it takes to fuel up your vehicle is analogous to that of your latency. How fast can that I/O be serviced, or in this case, how fast can your car be fueled? But that's not necessarily part of this conversation. So we're now at 4 automobiles here. But now what if 3 more cars show up? In a most simplistic scenario, those cars essentially have to be turned away. They will not be buffered at that endpoint. They will be kicked back. So again, I'm generalizing here. But understanding that being kicked back and then having to be reset is not a good thing. Now, most of us, though, again, are now in the world of storage fabrics and HBAs, and those different elements in the stack have something called a queue in it. I like to think of it kind of analogous to that of a stoplight, and that HBA, in this simple example, has a queue depth limit of 3. I will only allow 3 vehicles through this particular device in order to get to the gas station. So I will not overrun the gas station. So the queue depth is going to be slightly lower in this simple example than my overall capacity of my underlying storage. I have 4 fuel pumps, but my queue depth limit, we've set it to 3 to not overwhelm it in this case. Now, of course, when one car finally finishes being serviced, now I let the next car through, and so on and so forth, right? So I like to think of these queue depth, as like those traffic signals. I think that's a pretty good analogy. But what happens as certain things get upgraded over time, just like we just did? We just invested in some really awesome storage. So now I happen to have 24 fuel pumps instead of just 4. But what if I never change the queue depth setting of my HBA? Where's everybody? I can service a heck of a lot more automobiles simultaneously now, but they're not being sent down to me because now they're being bottlenecked further upstream. How many people here have seen traffic and thought, why are these traffic signals? Why hasn't anyone changed these light timings? Because I'm sitting here, there's a whole bunch of people sitting here, but there's no cars going the other way. The light signals are completely out of whack. And this is a good example of that. So if I were to now change the queue depth defaults on my HBAs though, now I can of course send far more traffic through to my final destination, to the underlying fuel pumps. In this case, the light is green. I can keep going. I don't have to stop here. I can, now I can finally actually saturate and leverage and utilize my underlying, in this case, gas station, or of course, our underlying storage. So queue depth settings are oftentimes those defaults that were never really adjusted in the past, and we didn't really ever have to bother worrying about them up until the era of, well, now with super fast storage that's available to us. So there's a number of different places that you may have to check in order to potentially make modifications to your underlying queue depths. One of the things that this is related to is your virtual SCSI adapter. If you happen to be virtualized, for example, it's changing away from the legacy LSI adapter and using paravirtual SCSI adapters, and instead of just one, using the maximum of 4, for example. You, of course, want to distribute your volumes across those PV SCSI adapters as well. And then, as I was just kind of talking about, changing those queue depths. Going back to that original customer that this story is based upon, the VMware admin who's been doing VMware for 20 years had no idea what queue depths were because they never had to deal with it before because they were on legacy crappy spinning disk storage, right? So me, the non-VMware guy, had to educate them about queue depths, which is kind of funny. And once they cranked up those queue depths, performance is amazing. So a simple thing like that. So some of you, when you think about queuing, will be like, hey, Windows has, I've heard about these, different perf counters that are available to me in Windows, so you know what, I'm going to go check out some of those, right? So your average queue disk length and current queue disk length, I might go check those, and I might see those numbers are insanely high. But like a lot of different performance values, they're, I would argue, meaningless or don't have as much meaning until you consider something else. In this case, latency. Because if I happen to have, my current queue length being a very large number, but I'm servicing them really, really fast because my latency is super low, I don't really care, right? Because my I/O is still being serviced. I'm getting my data back really, really fast. And it's also important to understand that SQL Server will drive up your queue length intentionally because it does I/O in an asynchronous fashion. So it's not going to sit there and wait. It's just going to fire and forget and then go off and do something else until your storage subsystem can fulfill those I/O requests. So this is one reason why you may oftentimes see your disk queue length shoot up. But is it really a problem? Well, check your latency. If latency is high, then yeah, it's probably a problem of some sort. But if your latency is super low, who cares? So going back to the error 833, I talked about a lot of stuff here, right? But did I ever disclose a root cause? No. Because frankly, the root cause can be a whole heck of a lot of stuff. And what I'm showing you right now are quotes from the Microsoft documentation page. Blah, 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 the workload. Blah, 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 the workload. Blah, 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 the I/O path could be malfunctioning. Blah, 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 the I/O path has malfunctioning hardware components. The point is that that error message can be very, very broad, and the root cause could be a whole heck of a lot of different possible things, which is both kind of frustrating when we deal with one of these. It means that we need to start looking at a lot of different places, is really what it boils down to. Now, what I've actually just done over the past, 30, 40 minutes is actually taken you through the Microsoft methodology for troubleshooting I/O. So this flowchart is actually available on that URL down at the bottom, and basically everything I just talked about in the order, I riffed a few things here and there, but fundamentally, I just took you through Microsoft's process, and as they say in their documentation, this is what CSS happens to do as well. But fundamentally, it's all about just starting from the top down and going through a process of elimination to try and eliminate suspects as you go further on down the stack. Okay, so you can definitely dig into this a little bit more deeper, but hopefully you have an appreciation from a high level of how I've been eliminating different aspects, answering different questions as I essentially go through this flowchart to try and figure out where's my root cause. So if you've ever been to any kind of storage session, there are many different tools out there, perf counters, DMV queries. I also really like SP Who is Active. I'm not going to talk about any of these three today because, frankly, a lot of other people already have talked about them. I've even talked about them in the past. So you know what? Instead, for some tooling, I'm going to try and introduce you to a couple of new things that you may or may not have encountered before. The first is called SP Pressure Detector by a gentleman named Eric Darling, who I believe is doing a session after this one about isolation levels. He's got some really amazing stuff out there. I'm also going to show you something called Resource Monitor, not to be confused with Activity Monitor. It's one of those things that I didn't even know existed for the longest time, and it exists in Windows until Anthony Nocentino, my friend and colleague, showed this to me, and it's like, oh, this actually shows us some really cool stuff as well. And the third thing I'm just going to do a little bit of showcasing on, the third tool, is something called Process Monitor. Let's do a quick time check. Oh, we're doing really, really good on time. I am chugging along here. Before we get into the demo, let me actually pause and ask, are there any questions in the audience, since we got plenty of time right now? Yes, question back there. So the question is, I pointed out that, only consider, queuing if latency is high. So what is high latency? Really, the only way to answer that question is, so what is your storage subsystem, and what are you expecting for latency to be? Because, back in the day, latency in the 10s and 20s milliseconds was acceptable. But nowadays on super fast storage, you can get sub-millisecond latency on really, really awesome hardware. That's something that we do, for example. And oftentimes our applications have certain latency requirements. Generally speaking, in a transactional world, you want as low latency as possible. But sometimes if you're doing things on a more analytical basis, like data warehouse type workloads, you're generally speaking going to be more concerned about throughput rather than latency. So it's all about really what is your underlying hardware and what are your specific requirements, right? But I mean, if you're in the single digits, you're probably in a good place, unless you know you need to be in the sub-millisecond range. But if you're in the hundreds or higher, unless you're still on spinning disk and hopefully it's not a prod environment, then you're probably going to be in trouble. Does that help answer your question, at least just to kind of give you that ballpark? Right on, right on. Was there a question up front? Okay, cool. Question in back, yes?
When you're talking about the port configuration, is that something if you have access to the VM, you can check yourself, or do you really have to get assistant admin or network person involved?
So the question is, if when talking about the port configurations, is that something that you can check yourself? So there is a blog post that is in my resources at the end. It's actually command line stuff that you have to do in ESXi. It's not something that is exposed in the GUI if you want to mess around with your queued up settings. Question?
So, in companies we have separation of duties, right? I'm a DBA, I don't have storage access, but I know it's a storage-related problem. How do I convince the other guy to go and take a look? What can I do from this side of things that says that it's an issue from the other side?
So the question is, many of us live in a world where we are siloed, right? I'm a DBA, and I have a separate storage team, I have a separate Windows team, and so on and so forth. So what can I, as a DBA, do to try and, motivate my storage person to go take a look? Part of that just has to do with just building those bridges and also building up enough working knowledge on their side to better appreciate the things that that they have to deal with, and also coming to the table with enough facts, right? Hey, I think it might be a storage issue because this is what I've seen. I've done this homework so far, rather than just blindly throwing it over the fence. Oh, it must be crappy storage, right? Well, but is it or is it not? But hey, I think it might be a storage issue because you know what? From what I can see here, latency is this value, or I'm seeing this kind of performance characteristic, and this is unusual because this is what's been happening. What do you see on your side of the fence? Oh, you don't see anything on your side of the fence, storage admin? Then maybe it's actually something in between. So maybe I'll go to my virtualization admin next, or my network person next, right? So it's all about building that line of communication, but trying to come to the table with as much information and also an appreciation or general working knowledge, which is kind of what this presentation is about. It's like, hey, I remember hearing Andy talking about queuing. I remember Andy talking about this or that from the high level. Do you think it might be something along the lines of this? Or have you already checked into that and eliminated that, right? So hopefully that helps. Great. Any other questions? I think I saw one more hand back here. No? Going once, going twice? Cool. Let's pivot over into demo. All right, so first of all, I'm going to be showing you SP Pressure Detector by Eric Darling. We're going to skip over some of this stuff. I've basically just disabled memory grant feedback here just to help control certain behaviors here. So just to give you that overall kind of introduction to SP Pressure Detector, I'm using the help parameter here. And Eric has done a really good job of documenting all of the different capabilities about SP Pressure Detector. One thing I will caveat, and this is personal opinion here, is that SP Pressure Detector is definitely more of an intermediate to advanced tool. So you really need to understand what this thing is really reporting on. It does a fantastic job of summarizing a lot of deep level knowledge, and we'll see some of that in a minute, but it's not necessarily for the faint of heart. If you're brand new to this world, stick with some of the other tools first before you start diving into something like this. And there's a lot of other amazing things out there, like the SP Who is Active, for example, and starting with things like that. But in either case, number of different parameters in here that help you kind of zero in on what it is that you want. Maybe you want to look at all sources of pressure here. I'll use zoom in here to kind of dig into that. Or maybe I'm more concerned about CPU related elements or memory related elements. Understand that if you're looking at disk latency, there is a minimum disk latency threshold here parameter, and the default is something like 100 milliseconds. So that's just what Eric has happened to have put in here by default, but you may want to, again, readjust some of these different values. And you'll see in my demos, I'm actually just going to turn them down. So for example, minimum disk latency, I'm setting it to 1 because I'm doing everything on a local virtualized SQL server here on my laptop. I don't have to worry about a SAN or traversing any of that. So let me just give you a quick tour of the output. So the first section here is going to give us information about different SQL Server wait types since this server was last started. Of course, this is a virtual machine on my laptop, so I've only been online for about 6 hours or so. But I did try and run some workload here, so now we have I/O-related information on the file level here, because of course many of our databases now exist across multiple different data and log files, but I can see information about latency and the volume of data that has either been written or read from. And this one I find also really cool here too. So Eric has manifested all of the different performance counters that are available to us as well. So you can dig into some of that information, but understand that this information is also summary information as well. If you keep scrolling further on down in XML, he has also done things like manifest information about tempdb configuration if you happen to have a tempdb headache. Or, for example, if you happen to have seen low memory conditions, these will be manifest here, including when they happen. This one's actually kind of a cool one if you're familiar with like resource semaphore waits and so on and so forth. So, I like digging into this if this happens to be a challenge or a headache. And of course, right here is a summary of different memory settings on your SQL server. This is just a simple, small virtual machine. So for example, it only has 4 gigs of memory. But of course, hopefully your production SQL servers are a bit larger than that. And then some thread-related information. And if I was running workload right now, you would actually see an output of the underlying queries here. So that's just a quick tour of this. Some of the cool things that I like in here that I've put in some of the highlights is this one. So the page lookups per second is the number of requests per second of how often am I checking in with the buffer manager to see whether I happen to have a data page, in memory or not. I like this one because it's an indirect way, not a direct, but indirect way to get a better sense of how much data are my queries kind of churn through, right? Am I doing a whole heck of a lot of work? Am I doing less work or more work? Regardless of whether I eventually had to go out to disk or whether I stay in RAM. And I like some of these other performance counters down here that are specifically related to things like memory grants or other things that will steal memory away from the buffer pool. Like for example, lock memory is also one of those other elements that also must share the buffer pool with everything else. So these are some of the other cool things that I think is very, very useful. So I'm going to run a couple of different pieces of workload here. So these are just a couple of CTEs. They're just doing nonsense work to illustrate a point. So Yes, CTs create heartburn. I'm not a big fan of CTs, which is kind of funny because I remember when they first came out, I was a huge fan of them, but that's before I understood that they don't pre-manifest or pre-materialize your subqueries. So in either case, we've run that. We're going to take a look at SP pressure detector now that that workload is running. Now let's take a look at our results. Now again, this is all cumulative information, something that you need to be mindful of. But one of the things I kind of want to point out here is like the memory utilization here. I can actually now see, my buffer pool memory utilization and the amount of stolen SQL Server memory here as well. The code that I was running actually has some really horrific memory grants. So I've just driven this number up a lot. And remember, this is a small SQL Server. I only got 4 gigs. So I mean, 1.5 gigs that's being stolen for other purposes. That's not a good thing. Now extrapolate that out to what your production server might be experiencing. That happens to, of course, have a lot more RAM. But what if these percentages, what if these numbers are a whole heck of a lot higher and therefore out of balance? Not necessarily ideal. So something to potentially be mindful of when you're doing that memory level troubleshooting and trying to figure out what's going on underneath the covers. I like, again, that this information is all available to us. Now, I've been harping on the fact that this information is cumulative information, so this is one particular optional parameter that I really like. I'm now going to take a delta here. So this sample seconds means we're going to do something, wait 5 seconds, and then take another check. So I'm going to kick off my workload one more time. Run this, wait 5 seconds. And let's take a look at the results. Now, we don't do a delta for every single piece of information, but for the first 3 result sets, now I will have the sample size, and now I can actually see what weights, for example, did we incur in the last 5 seconds, my underlying disk workload. So for example, with this second result set here, notice that there's only one file here because this is the only file that I'm actually doing any work against. In this case, notice that it's only my transaction log file here as well. I wasn't actually doing any data manipulation, and the data pages are already in the buffer pool because I've been running the same query over and over and over again. So I was already able to load everything there. So I really like that. And then if I were to scroll down into the perf counters, how I pointed out, for example, like page lookups per second. So this was the first value, the second value. So really, you want to be looking at the delta over here to see the underlying difference. And then there's another column on the side that does, based upon the number of seconds, this is the per second value. But understand that these are all elements that are now available to you. So now I can get a better sense of, hey, at least in this 5 second period or this whatever second period you define, that I can now dig into some of that other information. If I was more worried about locks, I can look at lock requests per second. Memory, stolen memory issues, I can look into that here within that 5 second period. So this is another cool way to kind of slice and dice and look into what may have been occurring in that 5 second period. The other result sets here do not do the time delta, so it's just those first 3 result sets that do the time delta functionality. So this is kind of stemming from a Reddit conversation, but I'm not a big fan of table variables, and of course many of us have heard that table variables don't do anything against disk, right? They only exist in memory. Well, let me prove how wrong that is. So let's see, I'm going to execute this. I'm going to do the 5 second delta. I'm going to execute this where I'm creating a table variable and then just inserting a bunch of records into that table variable. And then the results of SP pressure detector actually show me that no, we actually did work in TempDB against both the data file and the log file in this particular simple example. So it's not just a memory-only construct. I was able to actually isolate and show that no, we actually did work against disk, even though it's a table variable. Going to do one more simple example here where I'm going to update a bunch of data here, but also note that I'm going to run a checkpoint operation. Just to refresh people's memories, a checkpoint operation is what will happen when I have updated some data and I have dirty pages of memory, and then I will flush the data pages down to disk. So we're going to basically force a bunch of data write, as opposed to, of course, the transactional log writes. So I'm going to put that in another window here. Update. execute. Oh, whoops, I did that out of order, but we should still be able to capture that. Should be no big deal. 1, 2, 3, 4, 5. So if I were to look at, for example, the disk output here, we did some work against a cookbook demo database, but my data file here, I got to scroll to the right, apologies, was that first record, total megabytes written. I wrote about 30 megs worth of data in that 5 seconds from doing those updates and checkpoint, update, checkpoint, update, checkpoint, which was the looping here. So just a different variation or different example to be able to see that, oh, I'm actually pushing down and writing out to disk on the data file versus the log file. In fact, if I recall correctly, this is the log file in this case because I'm doing a bunch of data updates, right? So that's all data that must be hardened out of the transaction log immediately. And we're doing a whole heck of a lot more on the T-log side than on the data side. So something that's kind of interesting there. So if you're if you're seeing some kind of disk-related contention, what am I doing more of? This is a simple example of how to break that down to basically see, oh, I'm actually hitting the T-log more than I expected as opposed to my underlying data files. I'm going to give you one more workload example. This is me running a backup here against a database that happens to have multiple files. So I'm going to kick this off, run the backup here. And now we see the underlying files that we've read from my data files. One of the things that bothers me about this is that you can't sort this information, so it's all unsorted, so it's a little bit of a jumbled mess. But that's why I highlighted these two. These are two of the data files in this particular database. Here's my overall latency against them. So not great latency, but here's the volume of data that we happen to have read out of our data files in order to execute our backup operation, for example. Okay? So, and then of course, if I were to dig into some of the other perf counters, I could do that. I could look at the weight, the weight stats up here, and see other elements of what happened over those 5 seconds. So that's the first demo, and that concludes SP pressure detector. I'm going to stop that workload. Let's go on to the second demo, which is resource monitor. So I'm going to jump over to the virtual machine itself. I'm going to minimize this. So in order to get to resource monitor, you're actually going to want to go over to your task manager. And like I said, I didn't even know this thing existed for the longest time. Oh, come on, task manager. There we go. I'm going to jump over to the performance tab, and then notice at the bottom, open resource monitor. This has been sitting in front of me for 20 years, or however long this thing has been around, and I never even bothered clicking on it. But we're going to click on it now, or actually I already have it up on another window. But this allows me to now dig in even deeper into what's going on, from the server level perspective. So I'm going to start with the overview side first. Now, let me zoom in here. We're going to ignore the charts on the right-hand side for now. One thing that's actually kind of cool here is that even when I'm in the overview pane, notice that we have a bunch of different checkboxes next to different EXEs. These are the different processes that are actually running on my server at any given point in time. So I can do something really cool, like, you know what? I only care about what SQL Server is up to, so I'm going to click on SQL Server server.exe, and now that has cleaned up my output, because now I'm only showing you what SQL Server is actually up to. So I don't have to worry about the rest of the noise from everything else. Or if I'm more worried about, in addition to SQL Server, maybe someone has logged in and is running Management Studio locally, or if I happen to be in an unfortunate situation where other application software is also running on my server, I can pin those EXEs as well in this particular application to better dissect, hey, SQL Server is doing this, and application X is now doing this and consuming these resources and fighting back and forth. So this is another cool way to really break down what else happens to be running on the machine at any given point in time. Of course, let's focus on the disk side, since this is a disk and storage kind of I/O presentation here. So I've pinned the SQL Server exe here, and then in disk activity, I see information about the response times, and then the volume of read and write information over here. Now this is a rolling 60 seconds worth of data. So that's where things can get a little confusing, because this value will kind of go up and down as if I were to have, for example, like a 10-second burst of activity and then drop back down. So understand that that particular behavior does exist. So let's run some test workload and see this in action. So I'm going to copy these stored procedures on over here to run that. And I'm going to run this one over here. So I'm just kicking off some random workload here just to kind of show you what then winds up popping up here. And then of course when I zoom in, it freezes everything. But in either case, I'm running some workload against my cookbook demo iSCSI database. I'm also running some workload against the cookbook demo database here. So these two different MDFs. And because it's a randomized workload, in this case, oh, hey, look, I'm actually doing some stuff against tempdb by dumb luck as well. For this example, I happen to be sorting by total bytes per second just to get a sense of who's doing what, and so stack ranking by total I/O, whether it be read or write at this particular time. I'm looking at my response time, so I'm able to see the underlying latency here. So hopefully these are good numbers for you. Remember how I talked about disk queue here? So let me scroll over here. You see how in the storage tab, I see the logical disks or the logical drives that are presented inside this virtual machine, and I see the corresponding disk queue length values here for any given period of time. So it's kind of cool to see, this sort of information if, for example, you're in the heat of the moment, performance is tanked. So you know what? I might throw this open just to get a better breakdown of what happens to be happening at a specific point in time. So I'm going to do this particular demo. This is actually something I just came up with earlier. So I'm going to switch over to the General tab and go to the Overview tab. So many of us run our storage array networks across Fibre Channel. But some of us will also use iSCSI, which goes across the network. So this is actually something I kind of stumbled upon a little bit earlier, so I decided to throw this in as a last-second demo. So I'm going to run some random workload against my cookbook demo database that's running against iSCSI, because I happen to have another virtual machine that is presenting storage as iSCSI here. And one interesting thing to note, come on, zoom it, is this. Okay, first of all, up here what I did earlier a moment ago, and I'm not going to scroll back and forth just to show you that I pinned the SQL Server exe, but then I also pinned system underneath. Because if I only pin SQL Server exe, under the network tab, all I'd be able to see were these two lines, that from the network perspective, I'm talking to these two virtual machines. But because I'm doing work over the network against iSCSI here, Magneto is my iSCSI server. So now I can actually see the network activity, because it's technically network activity in this case, even though it's disk activity from the perspective of SQL Server. So this is kind of one of those interesting nuances of if you happen to be using iSCSI, you also want to include system. Because remember what I said earlier about I/O being passed to Windows and then Windows orchestrating the I/O? So something else to consider from that perspective as well. And if you look up here at the actual, the file level output, you see that I happen to be, in this case, doing a whole bunch of read activity in this example. But hopefully this is giving you a good sense of how you can kind of slice and dice and gain some different insights as opposed to the perf counters or the DMVs that we're all used to. So I think that's actually a pretty cool tool. I'm going to jump ahead to our third and final demo, which is introducing to you to a tool called Procmon. Procmon, or Process Monitor, is part of the sysinternal suite, which is a free suite of tools from Microsoft. But I'm going to kind of take a little bit of a deviation here. You all remember what I talked about earlier about filter drivers? Well, I'm going to run that ftl-mtc command, instances command on my virtual machine right now. Come on, why are you not running? There we go. And then just kind of show you a quick output here. So these are the filter drivers that are available up on my, or that are running right now on my virtual machine. Now I'm going to spin up, Process Monitor here. Come on, Process Monitor. There we go. Now we get this user account control warning because Process Monitor inserts a filter driver. So I'm just going to use my defaults right now. We'll come back to these settings in a moment, but now I'm going to come back here to run this command, one more time. And now, look, we have a couple of new entries. Procmon24 happens to be sitting here because process monitor is actually interrogating our I/O through the stack. This is how we're able to get some more information here. So more of a kind of an esoteric thing, but again, that goes back to the earlier tidbit about filter drivers. So let's see what we can do here. So I need to set up certain settings. Of course, we have a number of different filters, so I'm going to set my operations to a read file and a write file, and then this one I want to do against a cookbook demo. So I'm going to go up here, filter, cookbook demo. Let me zoom in here real fast just to give you a sense of these different filters that are available. I've pre-populated a bunch of these just for time's sake, but notice that I've pinned the process name to being the SQL Server exe process here, the underlying operation. I just want read file and write file in this case, and I've also pinned the path to anything that begins with blah, 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 cookbook demo. So that way I get both my MDF, LDF, and NDFs captured in this case. And there's a whole bunch of different exclusions because there's a whole bunch of noise that I don't want to see in this case. We've applied our filter. Now let's run some code here. So I'm going to turn set statistics IO on, drop clean buffers, and then I'm going to do a fairly large update. But remember, I dropped clean buffers. So one of the things that we should be seeing is a lot of read-ahead scans. And set statistics IO is showing us that we did just about 1,500 read-ahead reads here. Now what I can actually see using process mon, come on, zoom it, are the discrete read file operations that were occurring against a cookbook demo MDF file. One other cool tidbit here is I can see the length of the I/O here. So this is a really cool way to kind of, if you really want to deep dive and dig into what is the size of my underlying I/O or to prove certain things, these are my read-ahead reads here. Of course, a read-ahead read, the I/O size can vary upwards to this particular value. But again, it's a really cool way just to kind of dig in a little bit deeper. This is where I can actually really get at some of this stuff. And if you want to get super Bob Ward nerdy and go down to the call stack, you can actually even do that too. Of course, I'm not going to, I don't know how to read the call stack, but if you don't want to tie a debugger to this, but you can actually see the scatter read internal and the other underlying information and the other underlying commands that are being executed underneath the covers when this operation occurs. It's actually really kind of cool stuff. This is where we're getting super deep, super nerdy. Okay. Just to illustrate one or two other use cases with this. Okay, just doing a quick time check. This is another table variables exist only exist only in memory is a bit of a myth here. Let's execute that. Jump back down here. I'm going to jump all the way to the bottom here. Oh, I didn't reset my filters. Whoops. So I'm resetting my filters to then just adjust to tempdb. I'll clear that out, and then I'll rerun my example query once again. And once again, we see that we wound up doing a whole bunch of writes to the tempdb transaction log because that code there was doing a whole bunch of insert operations into my table variable. These are representative of transaction log flushes, even within tempdb, even though it's just a table variable. So yet another discrete example, evidence and proof that yes, you're still going to see disk activity when you're simply using a table variable, a quote-unquote memory-only construct, which it obviously really isn't. All right, so we got a few minutes left, so I want to take things back home and kind of let's start wrapping things up here a little bit. I want to turn this off because this will incur a lot of extra overhead unnecessarily. All right. So I talked about 3 different tools for the last couple of minutes, but there's one more tool that I argue is the most powerful tool that we happen to have in our arsenal. The question. I touched upon this earlier, but I really want to drive this point home. For all of us to be effective troubleshooters and performance tuners, we need to learn how to ask questions effectively and how to effectively ask questions. So I have one more final story for you, something from the SQL Server subreddit. So this happened fairly recently where someone posted on the SQL Server subreddit and they were saying, hey, they're trying to load these large data sets and they're having these kind of performance headaches. Quote, statements are overloading the resources and slowing down my API. Okay, fine. So a whole bunch of other people started responding with all these different suggestions. Could it be this? Could it be that? Try doing this, try doing that. Play around with compression or partitioning or trickery or anything like that. No one else except me said, wait a minute, statements are overwhelming the resources. What do you mean by that? Tell me more. Okay, so the person, so I asked the question, how are you actually bottlenecking? What discrete symptoms are you actually seeing? You just said you're overwhelming the resources. That tells me nothing. So the person said, oh yeah, this is an Azure SQL. Well, wait a minute, why didn't you say that in the first place? And the main bottleneck happens to be log IO maxing out the load. Okay, fine. Well, what flavor of Azure SQL? Azure SQL, we all know, is just a generic term. Databases present themselves in multiple different ways in Azure. We can leverage them in multiple different ways. So I asked what flavor and service level of Azure SQL, and the answer was Azure SQL DB Gen 5 1 vCore. Some of y'all are laughing in here, but others in here who don't necessarily work with Azure don't necessarily appreciate the fact that our I/O is tied to the number of virtual cores you provision or allocate to your database. So when I saw 1 vCore, I said, full stop. You're screwed until you actually add more vCores. And I pulled this up. This is a subset of the documentation. You are limited from a log throughput and IOPS perspective with the number of vCores that you've allocated for your Azure SQL database. And if you're just running with 1 vCore, of course you're going to get terrible performance. And this is your production database? Seriously? Yeah, you need to spend a little bit more money and throw a couple more vCores at this thing. So sorry, full stop. All the other suggestions were great, but you need to deal with this first and foremost. Otherwise, you're never going to get anywhere. So it's all about asking the question, asking the right question, and digging in deeper. All right, so let's bring this home. So in summary, we've talked a lot about I/O and all the different pathways and some of the different consequences that we often face. And just hopefully have a better appreciation now for the different headaches that we see, even just from the front end with CPU and RAM contention, and in addition to possible bottlenecks that we may occur along the stack from a throughput perspective or from a queuing perspective. So yes, there are more stairs to climb. This is still a whole heck of a lot, because obviously this was just a survey session where I just touched upon a lot of these different topics. We can spend an entire hour diving into each one of these very, very, very specifically and very low level. But this presentation that you just sat through is technically a trilogy. So last year I did that session at the bottom, and a couple years prior I did that very first session. That very first session is actually only all about logical I/O as well. I kind of wish that that would be mandatory material for anyone who is a T-SQL developer, especially someone who's first learning about SQL Server in of itself. So if you've seen any of these other presentations, cool. If you have not, you may want to go back and check them out. So they're all related. They all kind of build upon one another. And again, all of these different URLs and my slide deck, of course, is available up on my GitHub. So if nothing else, just remember that we as performance tuners don't need to know everything. I definitely don't know everything. If you are blessed with a photographic memory, that's cool, but most of us are not. And just try and be mindful to remember these different tidbits, these different elements, so that you know that you can go back and reference them later. Because the true performance tuner is someone who is resourceful and knows where to find stuff. But in the end, you probably just need to fix your underlying crappy code. So with that, there's like 4 pages of resources here with articles by many people. It's a special shout out to Glenn. You got one of the resources down here. He's sitting in the audience over there. Hi, Glenn. So again, everything is up on my GitHub. Remember, github.com/SQLBeck. It's all the way at the bottom. It'll be on a subsequent slide as well. Now, I do want to ask that you take the time to fill out some feedback. But before you do this, I want to take a quick poll of the room. Did this session meet your expectations? Just give me a quick thumbs up or thumbs down. You won't hurt my feelings. Awesome. Thank you for that feedback. I really appreciate it. So with that, take the time to fill out the evaluations, because we as speakers put a lot of time into putting this stuff together for you all. So we would really appreciate just 3 minutes of your time to give us your feedback, your constructive feedback on how to improve these different sessions. But with that, SQL Beck is where you'll find everything, and I just want to say thank you for your time, and hope you have a fantastic rest of the past summit.